Well, good morning, everyone, and welcome here to the Launchpad and our live launch coverage of the 44th Electron mission on closer inspection. If it's your first time here, welcome. My name's Zach. I'm the founder and host here at the Launchpad, and we're just waiting for RocketLab to begin their live commentary coverage as we continue to count down to launch of today's Electron mission, T-minus 24 minutes and counting till launch. If it's your first time here, welcome. Take a moment. Let us know in the chat where you're watching from. We got people tuning in all over the world, and it's great to have you all joining us here. We've got Peter is in the UK. Great to have you here. We got Neil in Georgia. Steve's in Ohio. Liminal is in Long Island, New York. We got Sigun in South Korea. Ricky's in Tennessee. Kel6 is in Australia. We got Fix in California. Carson's in New Zealand, and we have Carl in Greenland and Just in India. It's great to have you all join us here live this morning as we count down to launch of a very exciting mission here today, as Rocket Lab is preparing to launch Japan's ADRAS-J spacecraft, which was selected by the Japan Aerospace Exploration Agency, or JAXA, for Phase 1 of its Commercial Removal of Debris Demonstration Project, or CRD-2. This is one of the world's first technology demonstrations of removing large-scale debris from orbit. ADRAS-J will demonstrate a safe and secure approach, known as RPO, with an H-2A rocket's second stage that was launched in January of 2009. It will then obtain images and other conditional data, such as the spin rate, the spin axis, and conditions of that second stage, and deliver observational information to help better understand the future of what needs to be developed for spacecrafts to actually allow for the disposal of that H-2A rocket's second stage and all sorts of other large-scale debris in the future. So, really amazing. It was here entering this era of space exploration that really just keeps pushing the technology forward, that we are now starting to begin work to be able to clean up low Earth orbit, which is super exciting to see, as there's a lot of space junk up there from the early space programs, and we want to make sure that low Earth orbit is stable. So there's a number of companies that are working and countries that are working on debris removal opportunities, and it's great to see something like Japan, where they are actually working on their own debris removal program for their own debris. The H-2A rocket is a Japanese rocket, so really great to see them working on that, but I'm sure they will work on other things. As we wait for Rocket Lab to begin their live coverage, we're continuing through the launch countdown, T-minus 21 minutes, 30 seconds and counting. If you have questions, you can send those in the chat by tagging us at the Launchpad, and I'll work on answering those live to the best of my ability throughout today's stream. Today's Electron rocket is launching from Rocket Lab Launch Complex 1B at the Mahia Peninsula in New Zealand. As I said, this is the 44th Electron mission in its history, the second mission of 2024, and they are going for, this is already the 34th orbital launch attempt of any rocket company this year, and we're only on the 18th of February, so we're pretty close to almost one a day for this year, which is really quite incredible, as we look to possibly break records this year. SpaceX goal 144, Rocket Lab had a record number planned for this year as well. So lots of launches coming up this year, and we're glad that and honored that you guys pick us to be your launch provider for launch broadcasting. Today's Electron launch is estimated to cost $7.5 million, and the vehicle stands 18 meters tall with a fairing height of 4.05 meters and a fairing diameter of 1.2 meters. Electron is a three-stage launch vehicle and is able to carry up to 320 kilograms to low Earth orbit, but today's on closer inspection payload, the ADRAS-J spacecraft, is a total mass of 150 kilograms, and it'll be getting deployed into a sun synchronous orbit, which is where that H-2 rocket second stage is. Now, looking into some of the details while we wait for Rocket Lab to begin their live coverage, this is the beginning of a 14-day window that opened today for this mission, and I'm trying to confirm with them whether or not these are instantaneous windows, because they are trying to obviously rendezvous with that second stage very specifically, so they will be working on that. To enable the rendezvous with a non-cooperative space object like the second stage, a highly responsive mission planning is required, Rocket Lab states. Rocket Lab only received the final perigee, apogee, and inclination from astroscale 20 days ago. Only then could they augment a perigee target for different days within that 14-day window, and those be selected, and then determine the burn times for the Electron's kick stage, which will be developed and confirmed at the T0, with only being defined on the day of launch, as it requires an accuracy of plus or minus 15 seconds. So this is a very specific launch for Electron. Quite incredible. As you can see, Rocket Lab's getting spooled up here, ready to go. So we're going to listen in to Rocket Lab Mission Control as they count down to launch of the 44th Electron mission here today, carrying one of the world's first large-scale orbital debris tech demos. T-minus 18 minutes, 20 seconds and counting to launch. Let's listen in to Rocket Lab Mission Control.
Looking at a live view of Electron on the pad at Launch Complex 1 in New Zealand as we prepare to launch an orbital debris inspection mission for astroscale. That is our 44th Electron you can see on the pad, ready for our second launch for the year at our scheduled liftoff time of 03:52 local time or 14:52 UTC. My name is Muriel Baker and I am joined by Neutron Systems Engineer Imogen Ray.
We're joining you from Rocket Lab Mission Control in Auckland, New Zealand, to take you through the final few minutes in the countdown for today's mission called On Closer Inspection. We've had a clear run through operations so far. The weather is green and our launch operators are tracking no issues with the launch vehicle, astroscale satellite or the launch pad. We're expecting the all clear for launch to come at the go, no-go poll, scheduled to start at the T-minus 12-minute mark to lift off. Before then, though, let's get to know a little bit more about today's exciting mission with astroscale. On board Electron is astroscale's ADRAS-J spacecraft, which stands for Active Debris Removal by Astroscale Japan. ADRAS-J is designed to inspect a derelict upper stage of a Japanese H-2A rocket left in low Earth orbit since 2009. ADRAS-J will approach and inspect the rocket stage in orbit with a view to better understanding what it would take to potentially dock with the stage in future and then remove it from orbit to eliminate space junk.
Once deployed from Electron today, the spacecraft will spend the next few months flying around the old rocket stage to better understand its condition and record how it moves in space, at what spin rate, on what spin axis, and more. Now, what makes rendezvous and proximity operations like this tricky is that objects like old rockets and dead satellites don't provide any GPS data. The debris has to be approached slowly and carefully to avoid collision before ADRAS-J can switch over to its own sensors for a safe advance. Meeting up with a piece of debris on orbit while travelling at speeds of around 27,000 kilometres an hour is as complex as it sounds, and a task that requires absolute precision to make sure the satellite is deployed close, but not too close, to the H-2A rocket.
Satellite deployment bullseye, though, is where Electron's kick stage excels. The kick stage has its own small but highly capable 3D printed engine called Curie that can start and stop on command to manoeuvre ADRAS-J into position on orbit with pinpoint accuracy. The kick stage has successfully deployed more than 170 spacecraft to precise orbit since 2018, and we're preparing for another bullseye today. Here's more from Astroscale to tell us about ADRAS-J and their overall mission to clean up orbital debris for the benefit of us all.
And if you're just joining us, welcome here to the launch pad.
Founder and CEO of Astroscale.
We are counting now T-minus 15 minutes, 45 seconds and count until launch of one of the world's first large-scale orbital debris removal demonstration missions launching on Electron from New Zealand. You can see the spacecraft there on your screen. T-minus 15 minutes, 30 seconds, and counting. We are awaiting in just a few minutes that go, no-go sequence, and we'll be listening in to Rocket Lab Mission Control for that, where we'll get the final go for launch, not only for weather, but for range, but also for how specific this mission is, that they are actually ready to be able to do this attempt at rendezvousing with this H-2A rocket's second stage to demonstrate being able to approach one of these type of vehicles that isn't outputting any sort of data to help them approach. Wanted to give a shout out to Kieran for giving a super chat there. Thank you so much. We appreciate that support. Lots of people just tuning in. If you haven't yet, take a moment, engage that like button, share out the stream, invite people to join us as we continue through the count. If you guys have questions, you can send those in the chat by tagging us at the Launchpad, and we'll work on answering those live to the best of our ability. We're glad to have you all joining us here as we continue through the count. Taking a very, very quick look at the launches that are coming up ahead to give you an idea of what's coming up this week. We do have a Falcon 9 launching from Cape Canaveral on Tuesday, a Falcon 9 launching from Vandenberg in California on Wednesday. We also have a Falcon 9 targeting February 24th from Florida as well. And then looking forward into the future, we've got many other vehicles hoping to launch this month, including another Soyuz and a bunch of Falcon 9s. We're also monitoring the countdowns for the final Delta IV Heavy and the next Starship orbital flight test, so make sure you stay tuned for updates on all of those. Ian sending a $4.99 super chat there. Happy Sunday. Thank you so much, Ian. We really appreciate that. Thank you so much for your support. You guys are awesome. All that goes into helping us expand our equipment and get our teams out to things like Starship to bring you guys the best possible coverage of everything space. T-minus 13 minutes, 30 seconds and counting. Let's listen back in to Rocket Lab Mission Control.
Today's launch is our 44th Electron launch overall, our second for the year, but it's the first time we've flown for ADRAS-J, and we could not be more excited to work with this innovative team.
We are now coming up on 12 minutes left in the countdown to launch, which means that soon our operators will conduct the go, no-go poll for this launch. Now, this poll will run through each of the mission's monitored stations to check on their status and whether they are ready to proceed with the final steps before liftoff. You'll soon hear our launch director for this mission, Michael Pearson, undertake that poll. So let's listen into Mission Control now and hear how it goes.
And all stations LD on mission proceeding with the go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCON.
VCON is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
RF.
RF is go.
MM.
MM is go.
And LD sub.
LD sub is go.
Okay, all stations, the go, no-go sequence is complete. We are T-minus 11 minutes and 11 seconds and counting. We are go for terminal count at T-minus 10 minutes, and from this time on, the 3-word hold procedure is in effect.
That was Mission Control confirming that Electron is ready for launch, and so is the range at Launch Complex 1. ADRAS-J's payload is healthy and now a step closer to being deployed to space. We are still targeting a liftoff time of 0352 local time or 1452 UTC and heading to a 600-kilometre orbit for today's mission.
You might have noticed from the camera view today that in those middle desks, you'll see our Space Systems team popping in and out as we're actually running 2 mission campaigns from the same control room. A big group of the team in there are operators from our satellite side of the business who are preparing to bring home our Winnebago spacecraft, the satellite we've built and operated for a company called Varda Space Industries. Over the past 8 months, our spacecraft has enabled its attached Varda manufacturing capsule to produce ritonavir crystals, a drug commonly used in antiviral medication for HIV and hepatitis C. With the manufacturing process complete and federal and range approvals for the capsule's re-entry, it's time now to bring the mission home.
Over the next several days of 24/7 operations, they will be commanding our satellite to perform a series of engine burns that will set Varda's capsule on a trajectory to land in the Utah desert no earlier than February 21st UTC. It is a super exciting mission our team can't wait to bring home, and it's great to see our Mission Control Center being used for both a rocket launch and a spacecraft re-entry campaign at the same time. While we wait through these final few minutes before liftoff, let's take a look at our Electron rocket for today's mission. Electron is the world's first carbon composite orbital launch vehicle. And we chose this material not because it looks cool to have an all-black rocket, but because it is incredibly lightweight while retaining its strength. And that enables us to dedicate more mass to payloads, which is crucial in a small launch vehicle with small mass margins.
We're often asked why we named this rocket Electron, and the hint lies in the unique engines that power it. Each Electron rocket features 10 Rutherford engines, 9 on the first stage and a single vacuum-optimised engine on the second stage. Inside these engines is another world first, electric fuel pumps that replace the traditional turbine system typically used in rocket engines. It was this electrical feature that helped inspire the name Electron. Now, designing a rocket is one thing, but building and launching scores of them is quite another. Few people understand this challenge better than our Director of Electron Production, Lee King. Earlier, he joined our Senior Director of Communications, Morgan Bailey, to talk more about the Electron team and what goes into building the most frequently launched small rocket in the world.
So building one small launch vehicle is quite the feat, but what's even more difficult is building 40 plus more. And someone who knows more about that than most people is Lee King, our Director of Electron Production here. Welcome, Lee.
Thanks for having me.
Look, it's launch day, it's super exciting for the team, and probably no more exciting and no more nerve-wracking for the team who have actually built Electron. Tell us what launch day is like for them.
Yeah, launch day for them is super exciting. They are personally invested. They spent many hours, weekends, public holidays building the vehicle. So for them, it's a labor of love, and there's no more greater feat than launch day. So there's an inherent buzz that goes through the factory on launch day. Everyone's super excited. They turn up in mission control and get to watch Electron take off the pad. Every single one of them are wanting to know, what was it I built on that vehicle? What did I touch? What part of my work has provided success to the mission? So it's a great day throughout the factory.
And you certainly never forget your first launch.
Never forget your first launch.
So tell us what goes into building an Electron. We have raw material comes in one door, a finished rocket goes out the other. You're in charge of what happens in between, and what exactly is that?
Yeah, so for production, there's at any one time multiple vehicles getting built at once. To ultimately achieve the amount of vehicles and the rate that we need to be building vehicles continuously. And for the feeder teams that provide all the components to vehicle integration, which is the final team that builds everything together, they are building probably 3 to 4 vehicles at one time in various stages of build. So those components will go through the different feeder teams and the likes of propulsion, mechanical production, composite production, and avionics production. They'll build it and complete end-to-end testing through all cycles of the build. They'll then provide that to vehicle integration, who will do the same. They will put all those components, it's the culmination of the production facility, ultimately. They put all those components onto the vehicle, complete end-to-end testing once again, making sure it is fit for flight, and then deliver that down to launch range.
Easy as that.
Easy as that.
So we've got a big year ahead. We've got some 20 plus Electron missions on the schedule. Obviously that's going to require some scaling up of the team. So I understand you've got a few roles open at the moment.
Yeah, we've got a lot of roles open right across all our different facilities throughout New Zealand and the US. And ultimately the skill set that we're looking for, we started in aviation, but really we've grown as a production facility. So while aviation is closely aligned with how we build the rocket, we really leverage all different types and all different skill sets. We have our own training process that we carry out through the production facility. However, we've even gone down the electrical route through electricians in building industry, electricians that are doing soldering of componentry, and then the likes of composite boat builders, the likes of trainees coming through from car apprentices, car building backgrounds, and again, aviation.
So you don't necessarily have to come from a space background to be able to build Electron?
No. Honestly, the biggest thing for us is, yes, you are bringing your life's experience and skill set to the facility, but nobody that starts here in a production sense has built an Electron. Nobody is a rocket builder. No one starts as a rocket scientist here. You will learn how to build Electron. We will give you the skill set that's required to be able to. What we are looking for is that attention to detail through your day-to-day life, through what you do in your job. We're not just looking for good enough, we're looking for that next level above good enough. And attention to detail starts there, but it's really your attitude, your willingness to learn, your hunger for the space industry, and your desire to really exceed your limits of what you thought was possible.
Sounds exciting.
Yes, it is.
Well, you've got a big day ahead of you, so I'll let you and the team get back to watching launch, but thank you so much.
No problem. Thanks for having me.
Right now in the countdown, we are getting close to a fully fueled Electron as we prepare for flight. We time our loading of kerosene and liquid oxygen to as close to launch as possible to make sure that the super cold LOX propellant doesn't warm up before we need to use it. Though Electron is a small rocket, it still requires more than 12 tons of propellant in the first stage to get to space. We should hear the call that at T-minus 1 minute that LOX loading is complete on Electron.
Shortly after that, the team will wrap things up with the first and second stage when they confirm that both are pressurised for launch. At T-minus 10 seconds, our launch director will count down with the clock to liftoff with Electron's Rutherford engines then set to ignite at T-minus 2 seconds. Let's hand over now to Mission Control. The first call we should hear from our operators at T-minus 2 minutes is the switchover to the rocket's onboard flight computer for the countdown. We'll be back with you shortly after liftoff. Show the way, ADRAS-J.
And if you're just joining us, you're looking at a live view of Launch Complex 1B at the Paria Peninsula in New Zealand, where RocketLab is counting down to launch of the 44th Electron vehicle launch, carrying a very special mission, ADRAS-J, one of the world's first technology demonstrations for removing large-scale debris. The spacecraft on board from Japan is going to go rendezvous with an H-2A rocket second stage that was launched in 2009. Listening into Mission Control, T-minus 2 minutes and counting till launch.
Internal power, FTS is green and enabled for flight.
LOX and recirculate. Anti-gathering is disabled.
Stage 1 and Stage 2 tanks are pressed.
I have flow engine approach enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
T plus 30 seconds and Electron has left the pad at RocketLab Launch Complex 1 in New Zealand, carrying the astroscale ADRAS-J payload. In a few moments, Electron will curb its engine power just a little to pass safely through the launch milestone known as max-Q, or maximum aerodynamic pressure. This is the moment during ascent when Electron will experience the most amount of stress on its way to space.
Cleared max Q.
And Electron is clear through max Q. All is looking nominal at T plus 1 minute and 24 seconds into the mission, with Electron cruising along at speeds of over 2,600 kilometres an hour and now at 23 kilometres in altitude. If you've joined us in the past, you'll be very familiar with the next 3 events happening back to back.
First will be the shutdown of the first stage's 9 Rutherford engines in preparation for when the first and second stages separate from each other, and then the engine will start up on Electron's second stage. Those actions are called out as MECO, which stands for main engine cutoff, followed by stage separation and then stage 2 ignition. We are expecting to hear those calls from Mission Control in just a few seconds.
AOS shadows.
Entered burnout detect mode.
MECO confirmed.
Stage separation successful.
Stage 2 ignition confirmed.
And that's MECO confirmed, stage separation and second stage ignition, all seen from onboard cameras on Electron. From the second stage, we're now getting a live view of the space-optimised Rutherford engine that's powering the mission to orbit. Up next is fairing separation in just a few seconds. We'll likely see those 2 fairing halves fall away after the split, so watch out for that on your screen.
Fairing jettison succeeded.
That was the 2 fairing halves successfully deployed there, introducing astroscale's payload to space. The mission is moving along in this second phase of the journey at more than 8,600 kilometres an hour now, at an altitude of 127 kilometres.
The burn on this Rutherford engine should continue for another 4.5 minutes or so before we get to the final stage separation between the second stage and the kick stage with astroscale's payload. For that event, we should see the Rutherford engine on the second stage turn cold before the stages separate. But before we get to that nozzle on your screen there will stay bright and hot as Electron continues on its trajectory to orbital insertion.
Electron has hit the 9,800 kilometre an hour mark on its way to orbit with astroscale. We're 4 minutes and 14 seconds into the mission now, having already completed liftoff, clearance through max Q, main engine cutoff, stage separation and second stage ignition. We have around 5 minutes left in this second stage engine burn to take the mission all the way to its target perigee of 522 kilometres. The perigee is the lowest point in an elliptical orbit, and from there the kick stage will coast around to the apogee of 600 kilometres. The kick stage will then ignite for final payload deployment of ADRAS-J.
You can see from the telemetry data on your screen that Electron is now moving very quickly towards orbit. The second stage is on a nominal trajectory with the astroscale payload, with everything looking great so far on this mission. At T+9 minutes is when that second stage engine is expected to end its burn and shut down for the final stage separation. And before we get to that, we'll first need to perform an action unique to the Electron rocket called a battery hot swap.
This happens only on the second stage of the vehicle, about halfway through the Rutherford engine burn time, when the first set of batteries that have been powering the engine's electric pumps are close to being empty. The battery hot swap replaces that first set with a new battery pack to power the engine the rest of the way. We're coming up on that milestone now, which should be coming across the net shortly.
Holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Hot swap successful.
Guidance is nominal 100.
We saw a flash of it there as it dropped away. The battery hot swap is now complete. Another major milestone with a green tick. Soon it will be shut down for SECO, or second engine cutoff. This is the same process the rocket went through for main engine cutoff on the first stage, before the stage separation earlier in the mission. The second stage engine will throttle down before shutting off completely, ahead of the kick stage separating with the astroscale payload, so the mission can continue on to payload deployment. SECO is scheduled for T+9 minutes 5 seconds, which we are coming up to shortly.
Stage 2 propulsion, still holding nominal.
You'll notice on the right side of your screen the fuel and oxidizer levels of the second stage engine. With just 22% of kerosene and 22% of liquid oxygen remaining, that puts us with just over a minute until the end of the second stage engine burn. With Electron moving at 20,000 kilometres an hour now, we're coming up quickly on orbital velocity. All right, 2 more milestones this side of the coast phase of launch. SECO, or second engine cutoff first, followed by kick stage separation. The vacuum-optimised Rutherford engine will throttle down ahead of shutoff, and then the kick stage will separate from stage 2. Let's check back in now with mission control and listen to those calls.
Entered burnout detect mode.
Terminal guidance, 18 seconds remaining.
SECO confirmed.
Stage 3 separation confirmed. And nominal transfer orbit achieved.
Great news there from Mission Control, and as you saw on your screen as that engine nozzle cooled down, we have had a successful second stage shutdown and separation of the kick stage. Astroscale's payload will now enter a coast phase as it completes its first lap of the Earth, with the kick stage on an elliptical trajectory. Once the dots connect is when the kick stage's Curie engine will ignite, placing the payload in its final orbit.
Once ADRAS-J has been deployed, the satellite will use ground observation data to determine exactly where its target H2A spent rocket is. So the satellite can cautiously approach and use its own onboard rendezvous sensors to get closer. The spacecraft's job on this mission is to understand what condition the H2A rocket is in. Is it tumbling? And if so, how quickly? What is its exact location? And can it be safely latched onto? This is called the Rendezvous and Proximity Operations, or RPO, and a successful demonstration of RPO on this mission could open up a world of on-orbit servicing possibilities, including active removal of space debris.
For now, the kick stage continues on its first orbit of Earth with Astroscale. We'll be back here on the webcast in about 50 minutes or so to take you through the final moments and payload deployment, set to take place at T plus 1 hour, 4 minutes and 30 seconds. See you here soon.
And if you're just joining us, welcome here. You're looking at live map tracking of the Electron's third stage carrying the ADRAS-J spacecraft, JAXA's first ever and one of the world's first ever technology demonstrations for moving large-scale debris. We are now 52 minutes, 45 seconds away from payload deployment. If it was your first time here, welcome. My name's Zach. I'm the founder and host here at the launch pad. And here at TLP, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together. We're just going to move that clock up to the corner here, and we are glad to have you joining us here live. While we go through the coast phase, we're going to be answering your guys' comments and questions, so you can send those in the chat by tagging us at the launch pad, and we'll work on answering those live. If you are going to head out, to make sure you take a moment and engage that subscribe button so you never miss another live launch coverage, docking, undocking, or return to Earth. But we hope you'll stick around as we wait for deployment of ADRAS-J here in about 52 minutes time. As always, take a moment, also let us know in the chat where you're watching from. Lots of people tuning in from all over the world as well. I know we had a question coming in just prior to launch, and I'm not sure if I can scroll back far enough to see who asked it. But someone asked a question on, will something like this help enable a future of larger scale, not just debris removal, but debris recycling? Will we be able to rendezvous with items and actually bring them home? I know a lot of people want us to bring Hubble home, and maybe even elements of the space station. And definitely, this is helping prove out new tech. This is obviously a Japan mission, but Japan does share a lot of their data with other partner nations, and it's definitely something that we're starting to prove how to rendezvous with spacecrafts that aren't outputting any sort of GPS data. We're using other satellites to track them, and then we slowly approach them with another spacecraft. So absolutely, this opens up that possibility. I think Rocket Lab's Neutron vehicle may open up some opportunities with just the type of fairing situation that it has, more the Hungry Hippo style. There's a couple other rocket companies that are small launch providers that have similar style. And then ultimately, Starship has that ability. The biggest thing isn't the rendezvous, it's how do you capture it and store it in a way that's safe to re-enter gravity. Because you can grab it in zero gravity and just, clamp around it. But you have to be able to secure it to be able to bring it home. And that's one of the biggest things that we have not tested and developed that technology for yet. T-minus 50 minutes, 15 seconds till payload deployment. Lots of people joining us from all over the world. If you guys have questions, you can send those in the chat by taking us at the launch pad, and we'll work on answering those live. Jessica, no booster landing today. Yeah, they are not recovering today's booster. They didn't make any reference of that happening here today. We got Fakel in the Netherlands. Great to have you here. We got Den in Denmark. Great to see you. We got Zombie is in Oak Creek, Wisconsin. Lebrac is in Los Angeles. Just checking in. Great to have you here. Thanks so much. Coltron is in O-Town, Utah. Great to see you. And Jimmy is in Cambridge, England. Richard bought 100 shares of Rocket Lab today. Maybe today. That's awesome. I know many people who have Rocket Lab stock. It's always interesting to watch their stocks on a launch day. See the emotions of launch. But great to have there. CB Spock, we had a spacecraft that could repair satellites and retrieve them. It was the Space Shuttle. That's very true. We did. Space Shuttle was designed to do that. So we, in a way, yes, we did already have that. That's a really good, actually, call out there. I wouldn't have, didn't necessarily think about shuttle because it was a crewed vehicle, but yes, absolutely. Seems like we're going for a lot more autonomous vehicles now. Excuse me. Early morning. Lebrac, have to match the speed and direction. Magnetics, if it's metallic, yeah. Magnets would definitely be a huge thing, absolutely. Penny, greetings from North Carolina. Must head out, but we'll keep streaming on my phone to see payload deployment. Appreciate that, Penny. You have a great day. And thanks for listening in through payload. William, hello. I'm a new subscriber from Pennsylvania. Thank you. And the launch was amazing, and you guys and gals are amazing. Thank you. Thank you so much, William. Welcome. We're glad to have you here. Appreciate you checking us out. Hopefully you subscribe, and we'll see you again. If you guys haven't yet, also make sure you join us over on our Discord. That's where our community hangs out in between streams, and I jump on there pretty often in general comms or live comms as well. We also, most of the time, have watch parties, so you can kind of hang out in comms and watch launches together. Ted, what is the second stage that the satellite will approach to? So it is from an H-2A rocket. So if you ended up watching JAXA's launch about a month ago. Excuse me, we need a coffee this morning. We need a coffee. About a month ago, Japan launched an H-2A rocket carrying a payload. So it's a large second stage of one of their launch vehicles. So just like SpaceX's second stage goes up to orbit, SpaceX is very unique that their second stage will actually perform an extra burn 99.9% of the time after payload deployment to put it on a deorbit trajectory. Sometimes it comes down within a couple of days. Other times, if it's a further out mission, it might take weeks. But they put it on a very specific orbit, that it is a decaying orbit or is a deorbit burn to bring it home, to not leave any junk in space. Andrew, thanks so much for becoming a Lunar Explorer. I appreciate you. Thanks for becoming that member. Make sure you join the Discord there to get some of those access. William, what is the payload max weight? I'm new from Pennsylvania. Thanks so much for sending that in. Electron can carry up to 320 kilograms to low Earth orbit. And today's vehicle is 150 kilograms. So just under half of what Electron can carry. For those that do pound weight, let's do that conversion for you really quick. 320 kilograms is 705 pounds, so that's the max Electron can carry. And it can today's payload is 330 pounds for it, and that's the only payload that's on board today's mission. Electron can carry multiple payloads, it has before, but it all depends on the mission. Aditya, how much space debris can this space Roomba pick up in its lifetime? That's a great question right there. It really all depends on how they are doing it. So this is just a tech demo to prove that we can rendezvous with a vehicle, take data from it, and really solidify our understanding of its orbit, its rotation, and its spin. Because it's one thing if you can come up to... Think about it as if it's a car in front of you. And you roughly know that the car's on the highway in front of you, but you don't know where. So you get on the highway, you get roughly where you think it is, and then you slowly start moving forward through the fog, trying to find it. Well, great, now you found it, and you can start to see it coming into view, but then all of a sudden you notice the car is actually going sideways in front of you. Still going the same direction, but now it's sideways. And it's slowly turning. So now we are developing this tech to rendezvous, and then actually determine what the spin rate is and the roll rate, so that if we do develop something like a claw that the UK is working on, that this claw is going to actually have to have thrusters to match its roll rotation exactly to the piece of debris, grab it, and then fire its thrusters to stabilize, and then do a debris burn, debris removal burn. So that's what they're proving today. They're not going to remove anything with this mission. This is just a rendezvous and gathering data mission, but it's a first. It's a milestone to get there. But a number of the vehicles that have been proposed and are in design and development right now for launches over the next few years to actually do debris removal demonstrations. Most of them are kind of a claw ramming style where they safely go up to it, they grab it or hold it, and they fire their engine, and it slows it down into a deorbit burn. They release the item, and then they turn around and they fire their engines again to keep them in orbit. So they would have a lifetime of number of things they could do, and most of those vehicles are designed for refueling. So then we're going to have Roombas that need new batteries and new fuel, or not new batteries, they'll have solar, but they'll need new fuel every now and again. So it's quite interesting to see a whole new sector of space exploration getting there. She's saying, same, I need a coffee as well. I just woke up. Good to see you as always. Yes, a coffee would be great. I ran down here just before we had to go live to make sure we were all set to go. So, absolutely, William. Thanks for sending in that question. Mealy, how many junk will be collected? So none on this mission. This is just a data collection mission. Lotus is asking, what are the red loops on the map? If you guys have questions, keep sending those in the chat by tagging us at the launch pad. I'm going to catch up on a few of the chat questions here, but keep sending those in. Lotus, what are the red loops on the map? Those are, if I remember correctly, Rocket Lab's own ground station coverage. So that was where they were having their data coverage for Electron. So Electron flies over top of one of those. We generally have really good coverage for the vehicle. Ooh, drip coffee. That sounds good. Now you're all talking about coffee in it, and wanted me coffee. Let's see here. Ricky's got to feed the kiddos. Thank you so much, Ricky, for those gifted memberships. He gifted 5 there. So thank you so much for that. And congrats to those that got there. Say hi to the kids for us. We appreciate you, Ricky. Ian just got back from getting a coffee himself. He didn't bring me one, Ian. Come. Ditch's got a tea. That's always good. Catching up on the chat here. Crane's asking, is it only Rocket with a so-called kick stage? I believe it's, well, that's literally what they call it. Some people would just call it a third stage or like an orbital transfer vehicle. So there's definitely other vehicles that have a similar idea to it, but they're all slightly different. Dancer, you need a coffee? It sounds like you need a can of coffee. It was a long night. We were doing some work late last night. So, and once you enter the world of VRs, sleep goes by the wayside. Catching up on the chat here. Patrick, what are your thoughts on the Varda return capsule? I haven't looked into it too much recently, but I do remember looking at it a while back. It's an interesting concept. It's for those that don't know, Varda did get a re-entry license for a space manufacturing capsule, and it is a vehicle and a company that is designing and building an infrastructure needed to make in low Earth orbit. And they want to they're built for orbital material production and re-entry. So it's a really interesting concept. They did just get a re-entry license, which is a huge milestone to them being able to actually do what they want to do. We'll have to wait to see if it happens. Re-entry is not an easy thing to do. The capsule for Varda, they're saying will hit up to Mach 25 or more on every mission before landing under parachute. So this is, re-entry is a big deal, but it's a really interesting concept, and I wish them well. We'll, of course, be following along, and we'll see ultimately what happens. There's a lot of new launch providers, a lot of re-entry providers, a lot of spacecraft providers that are all really new. Really exciting. Some have amazing ideas and are going to work, and some have amazing ideas and unfortunately are going to fall a little bit short, but that is okay. Lebrak, once elected president, I want to propose a real mission to the moon and Mars, sending robotics first, then humans. Multiple models to test all aspects, even robot animals. That's an interesting concept. I think with Tesla Bot, a lot of us have thought, why aren't we sending like Tesla Bot and the Boston Dynamics robots, to pre-set up a lunar landing site? They can deploy all the solar arrays and stuff, so we land and we just have to plug in a couple of cables. We don't even have to plug in the cables. The robots will plug in the cables. We are now just 38 minutes, 20 seconds away from payload deployment of the ADRAS-J spacecraft. Ian, let me come visit. I mean, you can come visit. There's not all that much to see. Give us a year and a half, and there might be something a little more exciting to see in Florida. But we'll keep that a little under wraps for now. But one day, hopefully. We have big ideas and big dreams. We would love to have people able to come visit the studio. Catching up on the chat. Grifter, how much recycling of the vehicle is a part of the license? Ooh, that's a good question. I'm going to have to dive into more about Varda on that to find that out. But thanks for sending that in. I will make a note of it and see if I can find that out. I'm not entirely sure, because that is a really big point of it, of, the idea of, if you have a spacecraft for re-entry versus what some of these other people are testing, the other ones just slow it down. So you're not kind of wasting not wasting, but you're not throwing away the spacecraft that went to slow down the debris. You're grabbing it, slowing it, releasing it, and then speeding back up. Where some of these other ones are spacecrafts that go rendezvous, dock, or encapsulate, and then bring it home, and then you're kind of one-shot it. So, Ian, investment opportunity. I mean, you can send us an email. We're always open to ideas. We're always open to conversations. Yeah, absolutely. Phil, will SpaceX buy ULA? No, and I don't even believe if they wanted to, they would be allowed to, because of the military contracts. So that's a big deal. ULA is being, according to all rumors and reports, has 3 bidders currently bidding to buy United Launch Alliance. 2 are... one is a company we don't know that's listed. The other one was a kind of a not newer company, but they were expanding from one sector into another sector. And the third we all know and some love, which is Blue Origin. Blue Origin, Jeff Bezos' company, is bidding to buy United Launch Alliance with their Vulcan rocket and the remaining Atlas. Delta IV Heavy will be launched in the next couple of months, which will retire that vehicle. But it'll be very interesting to see what happens with United Launch Alliance's future, going through this apparent proposal to it. I know Tory Bruno, the CEO of ULA, spoke at Space Congress a few weeks ago in Florida, and talked about when he took over that they've been at this point a number of times, talking about selling or dissolving or splitting into multiple companies, and that he and his wife and family and supporters, they fought a lot to keep it together, and He didn't really speak much more on the future stuff because obviously it's in negotiations. But ULA may only exist for, who knows how much longer, but will ULA be around by the end of the decade? I don't believe it will. It'll merge with someone, which I think can be really exciting, really invigorating. Bringing in a new era. I mean, imagine ULA and Blue Origin really merging. We got a new Glenn first stage with a simulated second stage out on a pad. We've had the first Vulcan flight. That'd be a really heavy hitter company, being Blue Origin and ULA merging together. So we'll just have to wait and see. Saw a couple of people saying, did it already launch? Yes, we had liftoff of Electron from New Zealand 29 minutes, 39 seconds ago. We're now tracking the third stage, or the kick stage. It is now currently over the middle of the South Atlantic, heading up towards the western portion of Africa, just missing Europe. Unfortunately, if you're in Europe, you're not going to probably see it this time. And then just skimming Iceland, heading over Greenland before it heads back down. We are now about halfway to payload deployment, 33 minutes, 30 seconds remaining until the ADRAS-J spacecraft is released. So you can keep an eye on that countdown in the top right corner of your screen. Top left is time since launch, and top right is till payload deployment. I know the black font's probably a little bit harder to read on the Arctic snow there. Sorry about that. Phil, ULA uses Blue Origin's engines already, and that was one of the interesting facts. Vulcan uses Blue Origin's BE-4 engine. So that's also a really interesting concept of, if Blue Origin buys ULA, one, they're already using their engines, so that's great. But two, what will happen? Do they need both vehicles? Do you need Vulcan and New Glenn? But both vehicles have quite a few military contracts and government contracts that they won, outbidding each other. So it'd be very interesting to watch how they navigate that merger. Dancer, in my view, of a ULA splitting should be the last option of the future of ULA. Yeah, I don't think the idea that they had in the past of dissolving into multiple companies is necessarily a smart idea. It can work, The idea is, do you have a launch provider, and then do you have, a rocket manufacturer and things like that. So there are ways it can work, but I think ULA's got a great track record, great vehicles, and we'll have to wait to see what their future holds. We're definitely in an era of changing companies and mergers and different things. Ian, I'll be in touch. I look forward to it. Make sure to add many zeros. No, I'm kidding. As we await payload deployment, 31 minutes, 15 seconds from now. Just a reminder, you can always head over to the Launchpad store. It is launch day, so you can use promo code LAUNCHDAY. Gets you 10% off of everything there. We're going to be adding more prints to our new print system, so make sure you check that out, including some absolutely incredible new TLP astrophotography. We're super excited to be working with an incredible astrophotographer joining our team to bring you some really special prints and captures there, so make sure you stay tuned for that. And we now have a digital download option, so if prints were a little bit too much out of budget, we do have poster, canvas, and metal print options, but we do also now have a digital download option where you can get a kind of a wallpaper copy for your phone or desktop. William, is the payload close to Africa right now, if my geography is right? So the best way to look for where the payload is right now is on the very center of your screen is Africa, the big landmass. And at the kind of bottom third of your screen, you're going to see a dotted white line going from the top of your screen heading down, and then kind of a weird triangle shape with a stick on it, and then a solid white line. That weird triangle shape, that's the spacecraft's tracker. So the dotted line is where it's going. The solid line is where it's been. So we are currently tracking that location, and it's currently heading north. So if you keep a close eye on that, it slowly moves across your screen. But great question. Thanks for sending that in. Dave, would a spacecraft spend more fuel going against the Earth's rotation? It can, absolutely. So the closer to the equator you are, and if you're launching the with the Earth's spin, against the Earth's spin, you actually are faster because you can go land-wise. You travel faster on the ground track for it because you're going there, but you're using Earth's gravity as well. If you're going with the Earth kind of thing, with the rotation of the Earth, you don't necessarily use more fuel. You use more fuel if you're trying to get somewhere faster. But if you're talking about like the ground track, you might be a little bit, I mean, you're talking minuscule numbers, but you'll be a little bit slower actually moving over land itself, but you could still be in orbit for it. And it all depends also on the elevation and what orbit you're in. 400 kilometers versus 5,000 kilometers, you're moving at much different speeds. Unknown sender, it's not an Apple AirTag. We can't ping it, but similar idea. If you're just joining us, welcome. We are 28 minutes, 12 seconds away from payload deployment of ADRAS-J. If you guys have questions, you can keep sending those in the chat by tagging us at the launch pad. We will work on answering those live as we continue through the count here today. We had a successful liftoff just over 35 minutes ago of the 44th Electron mission. The first and second stage performed beautifully, and now the third stage, their kick stage, is currently carrying the spacecraft in preparation for today's deployment. Taking a look at the mission briefing, we do have one final burn of the two burns of the kick stage. The first one is scheduled 50 minutes 36 seconds into flight. That's the first of two kick stage Curie engine burns. The final Curie engine burn will shut down 63 minutes 30 seconds into the mission. We do not have the exact length of time of those burns, but they'll hopefully come back on commentary and let us know that those have been successful. But we are now just about 14 minutes away from those burns of the kick stage, finalizing the orbit ahead of payload deployment. Payload deployment expected 26 minutes, 47 seconds from now, or 64 minutes, 30 seconds into flight. Ian, is that why they are going to a pole-to-pole orbit instead of a straight across? So this orbit is very specific to rendezvousing with that second stage. So this orbit is exactly designed for their target. Didn't have anything to do with what they wanted to launch or how they wanted to launch. This is to match what the H-2A was launched into in 2009. So yeah, it's, H-2As normally launch, I believe it's sun synchronous, where it kind of passes over the same place of the Earth with the same sun conditions every day, or same time every day. So that is why they're in this more polar orbit, but this is definitely a polar orbit launch. Coltrane, where do they plan on sending this junk once you figure it out? So it depends on what the junk is. There is an area called Point Nemo, which is just off the western point of Australia. It is the... We really need that coffee. There's a point called Point Nemo, which is the furthest point away from any landmass. And this is where we have dropped space stations before. This is where the International Space Station will be deorbited to, and Mir and a number of other stations have been in the past. So they try to aim for that. SpaceX re-enters kind of wherever they are, but they do determine set areas and do deorbit burns for that. So they are able to put sea closures in effect to make sure that there's no fishermen or anything in the area. But they do try to pick specific regions to be out of the way for it. Now, some of the debris up there that they want to capture, they'll just need to slow it down, and it will burn up and disintegrate in orbit and not even make it to the ocean. So definitely all depends on what the payload is and what they're trying to dispose of. A great question. Thanks for sending that in. William, the whole concept of what you're doing is mind-blowing. Yeah, there's so much happening with so many companies. It's truly incredible to see what they are all working on, really, a new era of space exploration. Yes, the spaceship graveyard. If you ever want to go diving, I'm not even sure if you're allowed to, but it's always quite the interesting place. Rocket Lab just had a round of funding, and in the release they mentioned having cash on hand for future mergers and acquisitions. Who or what should Rocket Lab acquire? Ooh, that's a big question. That's a really interesting question. And honestly, without really spending a lot of time looking into some of the other companies that are out there, I'm not sure really anyone. Rocket Lab is a really, really strong company. They have a lot of really incredibly talented departments and people. They're building solar arrays, they're building their spacecrafts, they're building their kick stages, they're building orbital transfer vehicles, they're building a lot, and they're working on Neutron now with their carbon fiber spacecraft, which will be a competitor to Falcon 9, and will be fully reusable. It's quite... the second stage of it necessarily won't be, but the first stage will be. But we'll have fairings attached and different things. So there's a lot to it that I'm not necessarily sure there's any major mergers on the horizon that I can think of that they need. They're just continuing to hire the right people. Stoke Space, Ken was saying, Stoke is awesome. I think Stoke is bigger than people think. We've had the privilege of speaking with them, and hopefully we'll get to go visit them sometime in the next year or so as they continue to develop and work towards their first test flight of their vehicle. We saw their hop test last year with Hopper 2, which was really awesome. And we've talked to them, and they have a really incredible future planned going forward. If you haven't seen our interview with them, we have like an hour-long interview where we dive into a lot of details about the future of Stoke. And it's really awesome. So check that out. That's on this channel here. That'd be a really interesting concept of a merger, but I really see Rocket Lab and Stoke, and I use the word competitors carefully here. Most of these companies, CEOs and their boards, yes, they are competing companies. They're competing on contracts. But the moment someone wins a contract, you go from a competitor to a supporter. If Rocket Lab has an issue and Stoke or SpaceX can help, they're going to, generally speaking, right? Like, they've already won the contract. There's no point in fighting at that point. You've won the contract, great, move on. So, we say it in our mission statement, space is better together. And I'm saying that statement I have heard that from multiple launch providers. You compete for contracts, absolutely. That's the business decision. But once you've won a contract to launch a spacecraft, when anyone is out on the pad of any launch provider, and they, have a launch and it goes great, everyone celebrates. And if something happens, everyone hurts for you because they all understand the feeling. And I think that's what's really special about the space industry. It's one of the few industries in such that, if you have a failure, other companies feel it for you too. Sometimes failures happen so much that companies don't make it, and that may benefit other companies, but no one company is cheering on another to fail at all, type of thing. So that's a really special part of the space industry for it. William, we need a USS Enterprise to travel through space. One day, my friend. We had a Space Shuttle Enterprise. There's some funny stories with that, but it never actually necessarily did a space mission. But we will have a Starship Enterprise. It's pretty much a given that we know Elon's going to name one of Starship's Enterprise. So we'll have that first Starship Enterprise probably in the next, I would say probably in the next 5 years. We will have a Starship Enterprise, which will be really, really incredible. Did you someday in the future there will be an island in Point Nemo made of space? It's a pretty deep point of the ocean, but yeah, I mean, eventually, absolutely. Timothy, an awesome launch was the launch from Wallops, Virginia. No, today's launch was from New Zealand. We're hoping to have another Electron launch from Virginia the next couple of months. Ken, Stoke has been working on 2 or more years for the reusable second stage. Yeah, they've got to be coming up about 2.5, 3 years at this point. Yeah, and that's one of their things. They focused on their second stage first. Then they're going now. They've proven everything they think they can on the second stage. Now they're working on their first stage, which is a really interesting concept to work the theory in that way. So they're continuing to work towards it, and we're cheering them on and excited to help tell some of that story as they continue on. But definitely, if you haven't yet seen that interview, highly, highly recommend it. I'll see if I can grab a link for you guys here in just a second. It was a privilege sitting down with one of their business executives to talk about the future of Stoke Space. So we appreciate their support in doing so, and look forward to continuing that conversation in the near future here. And just dropping the link for that interview in the chat here. We are T plus 46 minutes into flight. We are just about 4 minutes away from that first stage Curie burn. It's going to perform 2 different burns for today before payload deployment. We're about 17.5 minutes from deployment approximately. If you're just joining us, though, we're looking at a live ground track of the kick stage. It's currently passing over Africa, the western part there. A little bit harder to see, but it'll be coming back out over the North Atlantic, just skimming past Spain in just a few minutes' time. If you guys have questions, you can send that in the chat by tagging us at the launch pad. Ian beat you to it. Awesome. I appreciate you looking for that, though. I do appreciate that so much. We'd love to answer your guys' comments and questions. So you can send those in the chat by tagging us at the launch pad as we continue. If you enjoy what we do, make sure you subscribe so you never miss another live launch coverage. Docking, Undocking, Return to Earth. We're going to try to bring more of these longer streams through deployment with Q&As back, and we're excited that we're working on having a couple hosts join our team as well in the near future, which will be awesome to have some more people here to answer your guys' comments and questions. So stay tuned. Lots of things in the pipeline here at the Launchpad Network. My brother and I watched SSTOS during the original NBC run. We're also fans. That's awesome, Heavy Cruiser. Nice. Great series. Grifter, it is so strange watching first stage and fairings and batteries disappearing with no recovery. Yeah, some things like the batteries on Electron, it just doesn't even make sense trying to recover them. They're so small. So they just burn up in the atmosphere. So that's okay. That's part of rocket launching. Rocket launching will never be 100% reusable. It's just not going to be... Okay, not never. But it is going to be decades until we have every rocket vehicle that is a fully reusable vehicle. We're talking many, many decades. And we might never get there because there is always the idea that certain things, if you were trying to make SLS reusable, it would only be able to carry like half of what it can carry. Well, if you need it to launch a full weight of what it max can carry, we don't have room to do reusable. Reusable kills your launch payload fraction. So that's one thing. There will always be expendable rockets for very specific missions. Absolutely. And then some of the fairings and stuff, some of them just aren't designed to re-enter as well. They're small. The Electron's fairings are not big. Electron's not a very big vehicle. I don't think most people realize it. If you ever look up a picture of Peter Beck with Electron, it is actually a very small vehicle. You can kind of hug it. And, you know, they put it on rollers and push it around in a factory when it's fully stacked. So it's quite an incredible vehicle. William, best YouTube live show ever, in my opinion. I appreciate that, William. Thank you so much. That means a lot to us. We try. We try. We got lots of things in the work, but we try. And we're always here to answer questions. So we hope to see you back around here. Thanks for checking us out today. Jessica, hey, you got to make some space junk to retrieve some space. That is also a really fun part, Jessica. That's a great call out there. To launch these debris removal spacecraft, if you're launching them on other spacecraft that aren't reusable, are you making more junk? So how does that work? It's a very interesting story. Kind of almost a chicken and the egg kind of thing. I appreciate that, Ian. Thank you so much. It means a lot. We are now just 13 minutes, 30 seconds away from deployment. We are also expecting that we should be now at the point of that burn. That burn beginning on the kick stage. I'm just going to turn their audio back on here. It does have a little bit of everyday astronaut music, which we all know and love. Just to hear if we have that call out of kick stage burn. We're expecting that to be in about 10 seconds from now. Waiting for that call out. That burn should be underway. So no call out on the nets there for it, but the first of 2 kickstage Curie engine burns should now be underway. These 2 burns will happen between now and 63 minutes 30 seconds into flight, all the way down to just 1 minute before payload deployment. Payload deployment now just 12.5 minutes from now. If you guys have questions, you can keep sending those in the chat by tagging us at the launch pad. RocketLab made an April Fool's picture of Electron Heavy. Yes, they did. And it looked pretty good. I mean, let's be honest. Electron Heavy, that sounds like a good idea. Peter Beck, make it happen. No, Neutron's what's going to replace that. So it'll be awesome to see. Aditya, hope someday in the future they'll be able to make space junk collector ship that can process into usable materials for space stations. Yeah, absolutely. There's going to be an option there. It'd be awesome to bring debris back and sell it. I mean, would I buy a keychain of something that was a part of the space station at one point? I'd probably pay a pretty penny for that. In fact, I know I would. I think also with these new space stations in development, the question is, does orbital debris, and maybe this goes to what you're saying, Aditya, does it change from an idea of orbital debris is you're slowing it down to burn it up in the atmosphere to you're acquiring it and you're changing its orbit to bring it to a space station? And then they can work with it at a space station, almost like a space dock type of thing, if you're for the Star Trek fans in the chat. So there's a lot of questions on how that can all work. A lot of questions, a lot of theories. We're at a really exciting point in space history. Really exciting. Hey, Airvale, overslept the launch, but glad to see it went well. Yes, we're just about 10 minutes and a bit away from deployment. It was a good launch, nice and clean. Pretty standard for an Electron, but glad to be here, and sleep's important, so enjoy that extra little bit of sleep. William asking, when is the next launch? We do have the next few live streams scheduled, but to give you an idea here, we have a launch targeting 3:11 p.m. Eastern Time on Tuesday. That will be a commercial mission on a SpaceX Falcon 9 from Florida. We have a mission at 11:24 p.m. Eastern on Wednesday, launching on a SpaceX Falcon 9. Yep, more Starlinks. That is launching from Vandenberg in California. There is a launch on Friday at 5 a.m. Eastern time from China, but we won't have any coverage of that. It's a known mission. It's one of the China ones that we don't get to see. And then we have later into the month a number of other Starlinks and different things that are still pending exact launch times. But for this week, you got a launch on Tuesday and a launch on Wednesday. And we should have another Falcon 9 on Saturday is what it's looking like as well. So 3 Falcon 9s this week, which is exactly what we're expecting to see if they want to launch 144 a year. Technically right now, if SpaceX was to do 3 a week, they are, I think we were running the numbers last week, I think they are 6 behind or 7 behind. So they're going to have to pick up the speed somewhere and catch up on that number. But we're sure they're going to be able to do it. Ian, I would definitely want a piece of the ISS, right? Like, that seems like such a great idea. Let's get a Starship, let's go up, and let's cut up the space station and sell it as keychains. I mean, it sounds pretty good to me. If anyone's doing this idea, I copyright, trademark, claim it. It was my idea, and I want royalties. Just putting it out there. William, wow, can't wait to see it. Great, thanks so much, William. We'll definitely see you around. If you have Discord by chance, or even if you haven't, maybe consider checking that out. It's where our community hangs out in between streams. Love to see you in there. We are now 8 minutes away from payload deployment. Tristan, why would we cut it up? So, I hate to be the bearer of bad news if you didn't know. The International Space Station is being retired at the end of the decade. Current plans are for it to have crews until 2030, and then in 2031 or 32 it will be deorbited as a station in a hole and thrown into the ocean. It's at the end of its life. A lot of the modules on station are already actually at double what their expected lifespan was when they were first made. So we are at that point. I mean, we're coming up to 30 years of the space station being in orbit, that it's going to be retired and disposed of, because if you don't have a crew on it or you don't have a spacecraft docked to it, it's going to slowly decay in its orbit anyways. So the space station has to do boost burns a number of times a year to keep it in orbit, and they'll just stop doing those, and then eventually they'll actually do deorbit burns. They are asking for proposals right now, and NASA and partners are working to find a commercial solution on who will actually perform the deorbiting and the disposal of the station. So lots of still unknowns. There are conversations that they could extend it again. The space station was actually supposed to be retired in the 2010s. So the fact that we're getting another 15 to 20 years on it is quite incredible. But as someone was saying in the chat, more will go up. Absolutely. Axiom Space is developing their own space station. They're actually going to build that space station attached to the ISS and then separate from the ISS prior to its disposal. So we will have Axiom Station in an identical ISS orbit, which is great. And we do have a number of other space stations that are being launched. We have Starlab, which will launch on Starship. And it is almost like the concept of an Airbnb of space stations, so that they're smaller stations that Dragon or something can dock to with a crew. But the idea is that you can buy your own. So, we might see universities start to have their own labs in orbit. Or you could rent space that, hey, I want to go up for so long to do a study, and you could rent space. So we're starting to see this change into commercial stations, which is really exciting. And there's a number in development. But there will never be, I don't think, right now at least there isn't plans for another international space station by the governments. Which I think is quite sad. I mean, through all the things our world has gone through politically, the International Space Station has been there for the last 25, almost 30 years. And is really a showing of, even for some of the world superpowers that don't love each other, that we're able to work together for the future of being able to live in space. And I hope we get to see that continue even with these commercial stations. And I think we will, but it will be a sad day to see the ISS go away eventually. We will see international partnerships working for the stuff with the moon, with Artemis, and then on to Mars, but we're also seeing that shift from government missions to commercial missions. And that's where things will change as well. And when they're commercial missions, it's all about who has the money versus necessarily going together. So we'll all have to wait and see what happens. Ian, you go right ahead, you go get rich, and then you go help all of us. Henry, let's get up there and cut it up. I'll put that on a shirt. That's a statement I don't think I've ever made before. That's a funny one. Clip for proof. Oh darn. I always forget these things are recorded. If you guys are just joining us, welcome. We are coming up to 1 hour since the launch of the 44th Electron mission carrying the ADRAS-J spacecraft for Japan. This is one of the world's first demonstrations of a large debris removal spacecraft that will rendezvous with a second stage from a Japan H-2A rocket that launched in 2009 that is not outputting any data, so they're finding it. They know roughly where it is, so they're launching this spacecraft, and over the coming weeks it will slowly approach the piece of debris and study it, proving that we can actually do so. It will not be removing it, but it'll be studying it and proving that we can do it. The final Curie burn should be happening any time now, and we are now just over 3 minutes approximately away from that payload deployment. Let's listen in to Mission Control.
Closer inspection mission for ADRAS-J, our 44th Electron launch. Today's mission left the pad at Launch Complex 1 under an hour ago with ADRAS-J's ADRAS-J payload on board, completing all the usual launch milestones like max Q, MECO, stage separation, second stage ignition, fairing ejection and battery hot swap during that engine burn, and then SECO and stage separation from the kick stage.
Having ignited its Curie engine a few minutes ago to circularize the mission's trajectory, Electron's kick stage will soon make a second burn to slightly adjust the course for ADRAS-J's rendezvous. We are about 45 seconds out from that happening, and as a reminder, we won't have views of payload deployment today, so we will track payload deployment with calls from Mission Control alongside a simulation of the process. Over now to Mission Control.
We are now approximately 2 minutes away from payload deployment. We are going to keep quiet and listen into Mission Control for these call-outs, but once we have confirmation of this deployment, make sure you have engaged that subscribe button so you never miss another live launch coverage, docking, undocking, or return to Earth, or exclusive one-on-one interview. And stay tuned for our Launchpad news updates, getting ready to start on our second channel, the Launchpad News. Also, make sure to join us over on the TLP Discord. It's where the community hangs out. It's free to join, and we would love to see you in there as well. And stay tuned for more opportunities on how you can join the TLP crew and help us with our mission to inform and inspire the explorers of tomorrow, because space is better together. We're now less than 90 seconds away from payload deployment. Let's listen into Rocket Lab Mission Control to wrap up today's launch mission. Let's listen in. And it is a very quiet net right now as we await for that final burn and deployment. So we do have audio patched in. It is just quiet.
Confirmed.
There's that final burn has been confirmed ignited. This is the final...
Great news from Mission Control. The kick stage's Curie engine has ignited for a second time for a brief 30-second burn.
Curie cutoff confirmed.
And good shutdown of the Curie engine, which means up next is payload deployment for ADRAS-J.
We are standing by for confirmation of payload deployment of ADRAS-J. Standing by for that call out. We'll be 15 seconds away from deployment. Curie engine has performed its final burn. The payload is in position, and we have deployment of ADRAS-J beginning its journey to the H-2A's second stage.
Mission is now complete. ADRAS-J is now on its rendezvous with the H-2A rocket to demonstrate its space junk removal technologies. Congratulations to Astroscale on reaching orbit, and all the best for your on-orbit operations, which begin right now. 2 launches down for the year and many more to go, including our 50th Electron mission coming up soon.
We will end the broadcast.
I love that you can see there the mission control view, Peter Beck in the back and the team celebrating. The ADRAS-J team now takes over, beginning their mission at low Earth orbit debris removal. And as you heard there, Rocket Lab counting down to their record 50th launch of Electron later this year. Here's a replay of the launch that happened just over an hour and 5 minutes ago. If it's your first time here, make sure to subscribe so you never miss another live launch coverage here on the Launchpad, because here at the Launchpad Network, it's our mission to inform and inspire the explorers of tomorrow. And from our TLP Canada studio, my name's Zach. We'll see you later this week for another launch of a SpaceX Falcon 9, or we'll see you over in the Discord, because space is better together. Have a great rest of your Sunday.